I'm Prashant here from Pragati the School. We are going to see the online classes for 10th standard students from Cbse and Karnataka SSLC stream. We will be seeing the chapter 10 part 2, that is refraction. In the previous part 1 we have seen reflection. So now we will be going through in detail what is refraction. I think you are able to see the picture. What does it show to you? A straw is kept in a tumbler which is filled in water. It appears as a broken, as if it is broken. Why? Because of refraction. Because of refraction. So we'll study in detail what exactly causes it to be seen like this. So whenever the light travels from one medium to the other, the direction of propagation of the light changes in the second medium. This is the definition of refraction. What do you mean by propagation? What do you mean by propagation? Propagation is nothing but movement. Movement. So whenever the light travels from one medium to the other, the direction of propagation of the light changes in the second medium. That means the direction changes. For example, see here, you can take this example. The light is traveling in air medium. This is the air. Okay, in the surrounding. The light is traveling. Take an example of the sunlight. The light is traveling in the air, and think that there is some glass slab kept here, and the light is coming from the source and it is touching this point, and when when it enters the glass, the direction changes. That's what the definition says. Whenever the light travels from one medium, that is air medium, to the second medium, that is the glass medium, the direction of the light changes. Simple. That's why the pencil which is kept in the tumbler appear as it is bent or it is broken because of refraction. See here, now this is a glass medium and again this is air medium. Think that the light is passing through the glass medium in a straight manner, and whenever it comes out of the glass, it is entering into the air medium, it changes its direction. From medium to medium, the light propagation, the direction of propagation changes. Very simple. And whenever you see a fish in a pond, how does the fish appear? The fish appear a little far away from the actual fish. See, whenever we see, we think that the fish is here. There is an apparent fish. That is a false image. Okay, we think the fish is here, but actually the fish will be here. Why? Because of medium. The ice is in where? The eye is in air medium. The eye is in air medium. The light is traveling. Then this is water. So the medium changes. So whenever the light is coming here, traveling straight, so it bends, it changes its propagation. Clear? Forgot to explain you one more thing. See, this is called as incident ray. The reflected ray is called as the reflected ray. The refracted ray is called as refracted ray. The refracted the refracted light is called as refracted ray. Understood? Incident ray, this is reflected ray, and this is refracted. See here, the incident ray, it is coming from one medium, it is coming straight, but whenever the second medium starts, it changes its direction. That is called as reflected ray. This is the angle I, angle R is formed. What is I? I is angle of incident. What is R here? Angle of refraction. You should not tell as refraction. but it is angle of refraction. Clear? So law says that the incident ray, the refracted ray, the normal, everything lie on the same plane at the point P. That point P is called as the point of incident. It is as good as first law of reflection. It is similar to it. Coming to the second law. Second law of refraction is also called as Snell's law. What is that? Snell's, Snells, Snell's law. What is it? What does the law say? The law say the ratio of sine of angle of incidence to the sine of angle of refraction. You have to tell here as refraction because we are studying about refraction. Very simple. The sine of incidence divided by sine of refraction is equal to constant. We call that constant as refractive index. Refractive index, which is denoted by a small letter n. Small letter n. This is the two laws. We will learn about the refractive index, which is represented by small n. Okay. Before that, as we know, the light travels the fastest in vacuum. The light travels very fast in vacuum. What is the speed? 3 into 10 raised to the power of 8 meters per second. Meters per second. We know that. But what is the speed of light in air? It is almost equal. See, here it is 299,792,458 meters per second. Approximately it becomes 3 into 10 raised to the power of 8 meters per second. Both will be same. But compared to vacuum, the speed of the light in air is very small. Very little small difference is there. See, the speed of light in vacuum is 3 into 10 to the power of 8, but the speed of light in air is 2.997 into 10 to the power of 8. That means we say it approximately 3 into 10 raised to the power of 8 meter per second. So we are learning about refractive index. What is refractive index? We know that as per the Snell's law. This is as per the Snell's law, sine of incidence divided by sine of refraction, that is equal to constant. That constant we call it as n is nothing but refractive index. So this is very important. Now come to this. See, this is a medium 1 is air, medium 2 is glass. You can take anything, or medium 1 is oil, or medium 2 is glass or air, anything you can consider. Okay, so whenever the light is coming in a straight line and it has to enter into the medium 2, then what happens? The angle changes. You can see it is not straight. It is not straight. It is at an angle. It is bending towards the normal line. Okay, why? Because of refraction principle. So here the two mediums are there. How to represent the two mediums? See here, the refractive index of medium 2 with respect to medium 1. How to represent that? You can write it as n to 1, that is equal to speed of the light in medium 1 divided by speed of light in medium 2. Why? Because the speed is different in air, the speed is different in vacuum, speed is different in glass, speed is different in oil, speed is different in quartz. So we have different refractive index for different mediums or different material available on earth. So we can write speed is nothing but velocity. So that's why we can write it as v1. Speed of the light in medium 2. That means velocity of light in medium 2 is v2. So n21 is equal to v1 by v2. You should remember n21, first 2 is coming, but here what is coming? 1 is coming. See here v1. N2, 2 is coming first, but here v1 should come first in the numerator. Remember, it is opposite. So n21 is equal to v1 by v2. So similarly, the refractive index of medium 1 with respect to medium 2. How to represent it? The refractive index, n is refractive index. That means refractive index of medium 1 with respect to medium 2. Medium 1 with respect to 2. That if it is 1 is here first, then 2 should come here. See, 2 is coming here. That means speed of light in medium 1, medium 2 divided by speed of light in medium 1. Okay. That's how we can find out the refractive index of a different medium. So all these formulas are very very important. You should remember or by heart. Okay, we have seen refractive index. Now we'll see what is absolute refractive index. Refractive index is represented by small n. Absolute refractive index is represented by small n. Below a small m has to be written. So nm nm, that is nothing but absolute refractive index. Okay. So if medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to the vacuum. Okay. If the medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to the vacuum. Understood? So medium 1, see here, n to 1. So medium 1 is air, medium 2 is glass, for example. So n to 1, n to n, refractive index of n. This is just a simple refractive index. It is not an absolute refractive index, what we are seeing here. It is a simple refractive index, n to 1. That means 2 means here 1 should come, right? So the speed of light in medium 1 divided by speed of light in medium 2 is equal to v1 by v2. Instead of n21, it is simply represented as n2. We can write it as n2. Okay, see here, n2 is equal to v1 by v2. So this is a simple shortcut you should remember. Then coming to the absolute refractive index. What is absolute refractive index? Nm is absolute refractive index. Always check that will be the speed of the light in air divided by speed of light in the medium. The speed of light in air will be common. We have to consider the speed of light in air. What is the speed of light in air? 3 into approximately it is 3 into 10 raised power of 8 meters per second. So that will be common. If they ask the question about absolute refractive index, Nm is equal to speed of light in air. In all the cases, numerator remains same. So the speed of light in air can be represented by small c. Then speed of light in the medium is nothing but velocity can be represented by small v. So Nm is equal to c by v. Clear? Nm is equal to c by v. What is Nm? It is absolute refractive index. Clear? We can see the absolute refractive index, or simply it can be called as refractive index. Okay, now we have to change. If it refractive index means there is nothing but absolute refractive index. Absolute refractive index of some material. You can see they are given here as just refractive index instead of absolute refractive index. Why? Because both are same. Both are same. Okay. Now we come to here refractive index of water. It can be represented by NW. How much is that? 1.33. Come here, material, and where is material medium? Where is water? We can search air, ice, water. Yes, water is here. What is the refractive index? 1.33. What is the refractive index of crown glass? Just check it. Crown glass. Where is crown glass? Crown glass, crown glass. Crown glass is here. What is the refractive index? 1.52. Right? And what is the refractive index of diamond? Diamond is 2.42. This you should remember always. Always this has to be remembered because important. This is the material which has got the highest refractive index. Diamond is 2.42. Air is almost 1 because 1.0003. It can be rounded off to 1. Water is 1.33. So at least 3 or 4 you should remember. Important. Okay. So you know how it has got refractive index of water. That is nothing but Nm. That is speed of light in air. See, speed of light in air should be common. That is 3 into 10 to the power of 8. Okay. Then speed of light in medium. So speed of light in water, we need to understand what is the speed of water. You need to get the data and divide numerator by denominator and we'll get this value 1.33 for water. Okay. So this is the refraction example Whenever you keep a pencil inside a tumbler which is filled with water, it appears at it as it as if it is broken. See why? As I said, because of refraction. Because the light, see, the light travels in the air and it touches the water and suddenly it changes its direction. Suddenly it changes its direction at an angle. Propagation changes. So that's why it appears, the pencil appears as if it is broken or it is bent. This table is important. The order of optical density increases. Optical density increases. Here also same. See, optical density is maximum by diamond. Why? Because that is the hardest material. This concept you should understand very clearly. One more thing here. You can see here the same thing what I explained there. The ray is coming here, light ray is coming here, and in the glass, what happens? It changes its direction. It is moving instead of going straight, instead of going making a straight path. What happens? It is bending. What angle it is bending? 34.5 degree. It is making an angle the with the normal line. Okay, it is making an angle with the normal line. What is the degree? 34.5 degree. And coming to water, which is out of glass and water, which has got the highest optical density. Glass has got the highest optical density, and the light ray is passing from the air and it is entering into the water. What happens? Instead of going straight, instead of having a straight path, it bends and it makes an angle 40.6 degrees centigrade with normal. That means the angle is more, right? So it shows that it is not going, it is not bending too much towards the normal. Why? Because it is less denser. It is less denser compared to glass. The light travels easily in the water. This is the experiment what we can see. See here, harder the medium, the ray tends towards the normal. Harder the medium, the ray tends towards the medium. Harder the medium means more the optical density. Higher the optical density, the ray tends towards the normal. That is the overall medium. It's the same thing. Optical density increases from here. From here it starts, and as it goes down, the optical density increases. Again, it will again it comes here, and again from here to here, optical density increases. How to find out the optical density? You can just see the refractive index. If you see the refractive index, if the refractive index is more, optical density is more. Simple. See, there are three liquids they are given. What is one they are given is kerosene, other thing they are given turpentine, other thing they are given water. Out of this, they are asking us to find out in which of these does the light travel fastest. Give the number 1, 2, 3. So as you know, the optical density of water is very less compared to all the things. So this is number 1. That means it force the light travels fastest in water first. Then comes second. In kerosene, it travels faster but much slower than water. So turpentine is much thicker because refractive index is 1.47. So this comes third. So light travels faster in water, second fastest in uh, kerosene, and third fastest in turpentine. So as optical density is lesser, the speed will be more. If the optical density is more, the speed also will reduce. The speed will reduce. Clear? Refraction by spherical lenses. We have learned about the spherical mirrors. Which are the two types of spherical mirrors we learned in reflection? The spherical mirrors is also called as curved mirrors. So there are two types of mirrors, that is concave mirror and convex mirror. Now we are studying about the spherical lens. We are studying spherical lens. So The lens is bound by at least one spherical surface. See, these are the different types of lens. This is concave, double concave lens. This is double concave, and this is single concave. This is concave plus convex, one lens. This is double convex, single convex, concave, convex plus concave. Okay, these are the different types of lens. We'll learn that in detail in the next slides. So spherical lenses, how many types of spherical lenses are there? Here also same thing. So lens means convex lens, and see here, this is concave lens, convex lens and concave lens. What is convex? Convex already we know, it is bulging should be there. What is this? Double. They are telling about double convex. Double convex means both the side there should be bulging. That's why it is called as double convex. Double convex. Where is single convex here in this picture? See here, this is single convex. Single convex. We are not learning about single convex. We are going only for the double convex. So this is the convex lens. So there will be two spherical surfaces. One spherical surface, and this is the second spherical surface. Bulging outwards. It is thicker at the middle. See here it is thicker, and as it goes, it becomes zero. Okay. So that is the characteristics of a convex lens. And again we'll come to the concave lens. Concave lens, you can see here, it is thinner at the middle, thicker at the edges, thicker at the end, thicker at the end. Okay, and here also there's two spherical surfaces, but here the curve is inward. You can see the curve is inward. If the inward curve is there, as you've seen in mirrors, here also, if the curve is inward, it is called as concave. It is called as concave. Clear? So which are the two types of spherical lenses? One is convex lens, other one is concave lens. Formation of convex. How it is formed? How to make the manufacture the convex lens? See, here two circle is drawn and the portion is taken. This is overlapping, correct? This overlapping portion is taken and it becomes a convex lens. It becomes a convex lens. And if two circles are drawn and the gap between the two circles, the gap between the two circles forms a concave lens. You should remember. Nomenclature. Nomenclature means names. Okay, what is the naming given for the nomenclature? So this, what is this glass? This is, what is A? This glass is double curve is there, outward curve is there. So that's why it is called as convex, and this one inward curve is there. That's why it is called as concave. So nomenclature, you are seeing is this O. What is O? See this O. What is O? Here also in this concave lens, O is given on this point. What is that point? This is nothing but optical center. What is that? Optical center. And where you're seeing this C? Oh, you're seeing is C1, here C2. So 2 we have. Okay, C1, C2. It comes in both concave and convex. Okay. So C is nothing but, what is C? Center of curvature. C is center of curvature. So C can be written as 2F1 here, 2F1 from this side left side and 2F2 on right side. Why there are two letters given here? Because if you want to draw the, there are two curves, right? One curve number one. For this curve number one, for this curve which I am showing, this is the center point. 2F2 is the center point. And for this curve, how to draw? If you given a compass and a pencil, You have to keep somewhere here and draw it, right? So 2F2 is the center point. So that's why there are two centers which will be coming. And what is F? F is already we know it is a focal point. There are two focal points. It depends on the curvature. It depends on the curvature. See, for this curve, for this curve, F1 is the principal focus or focal point. For this curve, F2 is the focal point. In mirrors, we call it as principal focus. In lens, we are calling it as focal point. So you should remember. There we call the center as P, pole in the mirror. But here in the lens, we should call it as optical center. You should not get confused. And what is this? P. This center line is called as principal axis. This center line is called as principal axis. Clear? You don't worry about this. Just for understanding, I had given here. Okay, just concentrate on these two. Come to the ray diagrams. Rules. We have seen already the ray diagram. What is the ray diagram? The diagram which is done with the help of the rays. See this one, this is a ray, correct? The light ray, the incident ray. With the help of the ray, incident ray, and this is what? Refracted ray. Incident ray, refracted ray. So with the help of the rays, the diagram is drawn. That is called as ray diagram. Rules are very important. So we need to see the rules. Rule number one. What does the rule number one say? Whenever a light ray is passing parallel to the principal focus, and it converges through the focal point. It converges through the focal point. That means it is converging. In concave, what is happening? Whenever the light ray is passing parallel to the principal focus, whenever the light ray is passing parallel to the principal focus, sorry, principal axis, this is the principal axis line, this line is the principal axis line. When the light ray is passing parallel to it, it diverges, it is going away from the center is called as diverging. That's why convex lenses are called as converging lens, because all the light is converge at single point. But concave lenses are called as diverging. Why? Because the rays go away. Once it enters the lens, it diverges. So rule number two, whenever the light ray focal point, passing through the focal point, it moves away from the lens. It goes out of the lens in a parallel manner. Parallel to what? Parallel to the principal axis. Here also same. See, it is passing along the focal point. We should not tell that it is passing through the focal point. It cannot pass through. Why? Because once it comes, it diverges. So you should say, when it is passing along, you should say the word as along the focal point, it diverges. It diverges in a parallel manner. All these rules are similar to the rules of reflection, isn't it? So whenever this ray passes through the optical center, it goes away from the optical center in a same manner or the same straight manner. The same single straightly it goes away. Here also same in concave lens. It comes here, enters the optical center, and simply it goes away. So that is the rule. So these rules are very important, and everyone should practice 5 or 10 times at home. Important thing is the image formation by convex lens. The image formation by convex lens. So we have to see the different positions. 6 positions are there where we can keep the object. We know AB. AB is an object. It is represented by capital A, and capital B. That is object. Image A dash by B dash, A dash by B dash. That is the image. So already we have learnt about this in the chapter part 1, reflection, isn't it? Same thing holds good here also. See, if the object is kept somewhere in the infinity, the object is kept somewhere in the infinity, that is represented by A, and this is represented by B. Arrow side is always A. Okay, the arrow side is always A. Clear? So this object is kept at infinity. Infinity, it means very, 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 very far. Very, very far. You can take an example of a sun. Sun is kept at infinity. The rays are coming from the sun. Object is AB is sun. You can take it as sun. So many rays are coming. Ray 1, 2, 3, 4, 5. So many rays are coming. What will happen? Once the ray comes, the rule number 1 says that whenever it is coming parallel to the principal axis, it touches and it diverges. It diverges and passes through focal point. Every single ray which is coming converges to single point, that is focal point. Focal point. When is the condition? The condition is when the image is kept at infinity. Infinity. Okay. Or what is the size of the image? It is highly diminished. That means very, very small. Small like a dot. See, point size. And what is the nature of the image? It is real and inverted. It is real and inverted. That means real and inverted means it will be real. Dark line should come. It is inverted. How it should be represented? Always the arrow edge side should be A. Okay, A dash, and this one is B, B dash. Correct. But are we seeing the same kind of thing? Are we seeing the same this one here at this point principal focus? No. Why? Because it will be very, very, very small. It is the small point size. The similar, the same thing what I have drawn here, it will be in the form of point. That means the size will be very, very small. So but it will be real and inverted. Next, the second condition is beyond 2f. See, C is here, that is center of curvature. 2f beyond CF, that means just below, just behind, beyond C, you can keep the object AB. And here also the important thing what you should learn is the two rays comes out of the object. That is, this is the ray number 1 and this is the ray number 2. Two rays should come out. Except from infinity, all other conditions you should remember this rule. That means two rays will come out from the head for easy drawing of the diagram, for easy understanding. So ray 1 is coming here, ray incident ray 1 is coming and hitting, passing through the focal point as in this case, and second is passing through the optical center. It goes straight and it meets here, and both the lines cuts here. Wherever the point cuts here, the arrow head of the arrow edge should come here. Okay, arrow head of the arrow, head of the arrow should head of the arrow should come this side, and plane end should touch the principal focus. And this is the image. See here, A dash, B dash. This is the image. How the image is formed? You can see this. You can see this. The image position is formed between f2 and 2f. See here, becoming the image is formed between 2 points. That is, 2 points are f2 and 2f2. So it is in between. It has formed. So diminish. Diminish means very small. Comparatively small. See, this is bigger and this is smaller. Comparatively, it is diminished. But real and inverted. Real and inverted. We can see the image. Real. Real means solid line should be there. Inverted. Arrow head is down. So that's why we call it as inverted. Coming to position number C. That means at 2f1. At 2f1, place the at 2f1 You place the object and two rays should go. One ray is coming here and it's passing through the F2. Second ray is passing through the optical center and here it meets. And here the arrow head of the arrow should come and complete the arrow A dash B dash A dash B dash. So where the image is formed? Image is formed at 2F2. Here where the object is kept? Object is kept at 2F1. Clear? See the image is formed at 2F2. And what is the size? Size is small size. Comparatively it is okay, almost similar, but it is small compared to the object. So it is real and inverted. We are seeing, right, it is real because solid line is there and it is inverted. So these three cases we have seen. We'll see case number D. Between F1 and 2F1, the object is kept here. A, B. Right? A, B. This is an object kept here. So as the law says, the two rays should come out. So one ray is coming parallel here and it is passing here. Right? The second ray is coming here and passing to the optical center and coming here and joining here. So here it meets. This point it meets and we have to draw the arrowhead. So it becomes A dash B dash. So you can see the image is bigger. The image is bigger compared to this one and it is inverted. So it is real and inverted. Correct? See here. It is real and so it is real and inverted. Come to case number E, that is at focus point. You keep the object at focus point F1. A and B is the object and a rule says two rays should come out from the arrowhead. So one is coming here and passing through the focal point. Other one is coming here and passing through the optical center. Where the image is formed? Image is formed at infinity. You are not able to see, correct? See here, the image is position of the image is formed at infinity, and infinity, infinitely large or highly enlarged. It is too much enlarged. We cannot see the image. It may fall on the sky, it may fall on some other planet. We don't know. It is very, very, very far. But the nature of the image will be real and inverted. Okay. And coming to the last case, you can keep the object AB here, AB here, where you are keeping it between F1 optical center. See, between focus F1 and optical center O. Okay. So what happens? The rule says the two rays, ray number one, ray number is passing parallel to the principal axis. It is passing through the focus focal point, and second one is passing through the optical center. Then here it cannot be passed. Why? Because it has to be developed back. Development. It has to be developed back. Once you develop it back, straight line has to be in a dotted line. You have to draw it, and here also backside you have to draw it a dotted line where the point should meet. Because if you go like this, it will not meet. Correct? So that's why you should draw it back, and the point will meet here. And the way the point meets, you have to draw the arrowhead. Arrowhead should come here, and you should draw it here. And why it is drawn in a dotted line? Exactly, because it is a virtual image. Virtual image is represented. Real image is, see, this is an image. Real image is represented by the solid line, but virtual image is represented by dotted chain line or dotted line. So what is the size? Size is highly enlarged. It is highly enlarged. See, highly enlarged, and it is virtual. It is virtual, and it is vertical or erect. See, erect means it is standing straight. So these are the 6 conditions: A, B, C, D, E, F, and this whole table you should by heart, and you should know. Even in the sleep also you should know the positions. Okay, you should practice in such a way. image formed by concave lens. Convex lens we have seen. Concave lens, only two conditions are there, the condition A and the condition B. See, the condition 1 is object is kept at infinity. The object is kept at infinity. See, the object will be kept somewhere in infinity, that means in the space. Or it can take an example of sun or moon. The light rays are coming from them. This is A, B. This is the object. What example we have taken? The object might be sun or moon. From there, from the space, the light rays are coming. We know the rule. When the incident ray comes parallel to the principal axis, convex, since it is a concave lens, what will happen? It diverges along the focal point. So it is going along the focal point. And here also same, one more ray is coming, it is also going along the focal point. This is, and where the image will be formed? Where the image will form? Image will be formed in front of the lens only. Where? Here. See, here the image will be formed. That means already dotted line is there. That means what is the meaning? It will be, see here, the nature of the image will be virtual. It is not real. Virtual, and it will be erect. That means whatever sun is coming, the image also will be like this only, but it will be very, very, very small. See, erect, but it will be virtual. Virtual means it will have the dotted line. If the dotted line is there, it is virtual. But can we see it? We cannot see it. But why? Because it will be highly diminished, highly diminished and point sized. Point size. This is one condition. Coming to condition number B, between infinity and optical center. Between infinity and optical center. Anywhere in between you can keep it. So you can, this one is represented by AB. Object is represented by AB. So we know the rule. The two rays should come. Ray number 1, ray number 2. So when the ray 1 passes parallelly to the principal axis, it diverges along the focal point. One more line, one more ray passes through the optical center. That means both are meeting, right? Both are meeting, and here the image is formed. See, that is the beauty of concave lens. Where the image will be formed? In both the cases, the image will be formed in front of the lens only. In front of the lens only. So image is formed here. It is diminished. That means the size will be small. It is virtual and erect. You're seeing here, right? Virtual dotted line is there. That's why it is virtual. Erect means is standing up. So this is images formed by concave lens. Hope you have understood. And coming to the sign convention for spherical lenses, it is very, very important for solving the numericals or the problem. So you can see here, x-axis, y-axis, same thing. If x-axis, if you go like this, what will be there? It will be, if you coming from 0, this point is called as, this point, what is there? It is called as O or 0. O. So if you start dimensioning, what will come? It should be plus 1, plus 2, plus 3, plus 4, plus 5, it will come. And if you go like this, you can see here minus 1, minus 2, minus 3, minus 4, minus 5 they are given, isn't it? So if it come here, it will be negative. If you go like this, on top, you know already, new Cartesian system, right? This is positive. If you come down, you can see here minus 2, minus 3, minus 4, everything. So the minus value should come. Same thing, see, upward positive, downward negative, correct? And this side, if it comes from there, it is negative. If you go right side, it is positive. Right side, it will be positive. The right side it will be positive. Clear? Upward will be positive, downward will be negative, left side will be negative. If you go towards right, it will be positive. That means both for this convex mirror and this concave mirror, the sign convention is same. The sign convention is, see, this is convex mirror. What is this? This is concave mirror. So both the sign convention will be same. So remember this, very very important. Coming to the length formula, already we have seen the mirror formula and the magnification in reflection. In refraction, we are seeing the lens formula and magnification. Why? Because we are studying about lens. So lens formula, what is this? 1 by V minus 1 by U is equal to 1 by F. Right? 1 by V minus 1 by U is equal to 1 by F. We know already what is U. U is nothing but object distance. U is nothing but object distance. What is V? V is image distance. What is small f? It is focal length. Okay, it holds good for both convex lens and concave lens. Coming to the magnification. Magnification is the ratio of the height of the image and the height of the object. What is magnification? It is the ratio, the height of the image and the height of the object. So height of the image is h dash, height of the object is h. Okay, it is given clearly here. And magnification is represented by small m. Okay, the correlation formula also it can be written. So magnification m is equal to, we know h dash by h, that is equal to plus v by u. V by u, that is object distance. U is object distance, you know, and v is image distance. So all the three formulas, 1, this is 2 and 3, all the three formulas are very very important for doing the numericals. The power of lens. What is the power of lens? The power of lens is defined as the reciprocal of its focal length. Power of lens is defined as the reciprocal. Reciprocal means fraction. Reciprocal of its focal length. That means 1 by f. F is focal length. See, the f is focal length, and p is power. Power of lens. P is power of lens. P is power of lens, and f is focal length. F is focal length. Clear? P is equal to 1 by f. That's what you can remember. And what is the SI unit of power of lens is diopter. Okay, diopter. It is denoted by the letter D, capital D. And if at all the doctor writes P is equal to the power is equal to plus 2.0, 2.0 D, that means 2D. Plus 2D means the lens prescribed is convex. Convex lens. The lens, whatever the human wears, it will be very very thicker. By seeing the spectacles, we can find out whether it is concave or convex. So it will be thicker. So if plus 2D is given, it is convex lens. If it is minus 1.5D, it is minus 1.5D, it means the lens prescribed is concave lens. Hope you have understood all these formulas and concepts. For being with me for such a long time, hope everyone understood all the concepts. So become thorough in the concepts. So this is a very important chapter and very high weighted chapter for the examination. If any doubts, please reach out to me or the class teacher. Thank you so much.